Welcome back to iMachine Learning class. In today's session, we're going to continue to review the core concepts of Python 3. Topics to be covered in today's session include functions, classes, and modules. So, what is a function? A function is a block of organized, reusable code that is to use to perform a single related action. Why do we need a function? First of all, if you think certain action will occur again and again, you probably do not want to rewrite code for the same operations within the action repeatedly. Reusability is a key consideration behind having a function. Basically, reinventing wheels is not a good idea. Second, within the function, you only have a single related action, so that is easier to understand what the function does. You don't want to have many unrelated actions in one function because the spaghetti type of code is very difficult to understand, debug, or maintain. The Python's syntax for function is like below. It begins with the reserved word def and the function name and then parentheses with parameters, also known as arguments, inside. The parameters or arguments are the variables that a function caller can pass into the function. Then operations are performed within the function body, and finally the function can return something back to the function caller. A very key concept associated with the function's parameter is the call by reference concept. What that means is if a function caller pass a value or expression to the function, like pass the argument to the function, that argument or that parameter is not having a clone or copy within the function body. What that means is whatever changes have been made to that argument or that parameter within the function body also influence or changes the value or status of that argument beyond the function body itself. The reason of that is the way that an argument is being passed to the function is by reference, a linkage to the parameter's memory location, not a copy of that argument. You are getting a memory location in a sense within the function body through the argument. So we are having one example as below. In this particular example, we are defining a function and its name is called display name list. And this function only takes one argument or one parameter, and it is defined as func param. So since this func param is a list, so now within the function body, the -1 means we are pointing to the last element of the list and assign a new value z to the last element in the list, which is passed through the function's argument. Then within the function, we'll just print out the value of the list after this particular operation, which is modifying the last element in the function. So the whole block is a function. Also remember, in this function, it returns nothing because returning a value back is or expression back is optional to a function. So this whole block is a function block defining a function called the display name list, which takes only one argument. Now, outside of function body, we first define a named list. Well, this is a variable type of list with three strings. A, B, C are the three elements of the list. Now, without doing anything, we just simply print out the named list. It's very simple printing operation. Then here, now we invoke the function. So this line is a function caller and is passing the named list as the argument into the function. So basically, what this happens is named list will be passed into this function, and the named list will be equivalent to the funct param of this function. And as we can know that the last element of the argument, function param, or here named list, will be modified to a new value, z. And after calling this function, we'll print out the outcome and we'll print out the value of the elements inside the list again. So basically that's what this function does, right? You can imagine that if you understand the code well, is you imagine that the name list initially has values of A, B, C, and after that, after the operation, you may see something like A as the first element, B as the second element, and the last element will become Z because the last element is got touched within the function body. So now let's try to run this particular example. This is example, and just as we have seen on the slides. So if we click here, we run it, and here is the outcome. Initially, the named list is ABC, as we know. And now we call the function body, passing the named list as the argument to the function. And after value is got modified within the function body, the new value within the function body printout already becomes A, B, and the last element Z. Now we jump out of the function body. At the end, since any argument to the function is called by reference, so any change made to the argument inside the function body still have impact outside of the function. So that's why we see even outside the function, now the name list have been revised into a different value, A, B, and Z. So this simple example is to illustrate the concept of call by reference of the Python's function implementation. Next, let's move on to the second topic of argument types. So in the Python, the arguments can take different forms. One way is just pass the argument in the function's caller, just pass the argument in the same order as the definitions of argument of the function itself, passing everything in order. So that's one way. The other way is if you do not passing the arguments in the function caller as in the same order as the function's definition for those arguments, you just specify the name of each argument specifically. In this way, there's no requirement to follow the positional order strictly. And there's something also called default argument, which means the function body may have 3 arguments. You may only pass 2 arguments to the function within the function caller, because the third argument has a default value. That's called default argument. And lastly, there's a variable length argument. We're not going to talk much in here, but just let you know there are different ways of specifying and invoking a function in terms of parsing arguments in the function caller. So we're going to look at one example called the student py. In reality, the student py is a class. So we're going to talk about class just in a minute, but now let's focus on the concept of different arguments. So within class, let's ignore class for a second. We have a different function called init. This actually is a special function for the class. Anyway, in this class, in this function, we have three arguments: self, name, and grade. So there are three arguments. And but the typical way you do it is just passing the argument in order. In this way, you do not need to specify the name of each argument. And I want to show you another example. And this one is also init and under a different class. And in this one, the last one is a GPA, which is one argument. Actually, this one is a default argument because in the definition of the function, we already give a GPA value of 3.8. What that means is someone somewhere later, when this function is being called and GPA is not being passed, or third argument, a last argument is not being passed, it will take a default value of 3.8. So this is the concept of default argument. The next topic today is class. Class is a concept of object-oriented programming language, also known as OOP language. Python has been an OOP language from its day one. Some commonly used concepts in the OOP languages are as following. First, what is class? Class is a user-defined prototype that includes data members, also known as attributes and functions, or may be called methods or procedures in other programming languages. Typically, you want to protect the data members. You do not want to directly expose data members for reading or for modification. So you rather doing certain access or modification to the data members through functions. This idea is called the data encapsulation. And thirdly, what is an instance? Typically, the way you use a class is to create an instance or object of class rather than using the class directly. There are certain special cases you may not want to define an instance of class and then using the class directly, but that's special case for special purpose. In most cases, the way you use a class is first you create an instance of the class. Thirdly, inheritance. So inheritance is the concept of you create a new class on the basis of existing class. The existing class is called parent class or base class, and the new class is called the child class or the subclass. One child class may have multiple parents. That means the new class may inherit both this class or that class, or even the third and fourth base classes. This concept is called multi-inheritance. So here are a few more terms associated with classes. The first one is called instant variable. Again, this is associated with the data variable, the attributes of a class. In most cases, the data members are not shared by all instances of a class. Such data members are defined inside a method that belong only to the current instance of a class. So this type of variables, data members, are called instant variable. And there's something else called a class variable, which is just opposite to the instant variable. For each class variable, it is shared by all instances of a class, so it's not unique to specific instance of the class. And instantiation, this just means creation of instance of a class. And constructor is a very special method in a class that is used to create an instance of class. Now let's look at a very simple example of Python class. Here we're defining a new class called a student. So this is how the syntax works. You have a class and a student. And first we have the variable, and this variable is a class variable because it's shared by all class instances. And this variable start with a 0, value 0. Then we have a method, and this method is called init, and you have underscore before and after. This is a very special method of the Python class, very special function of Python class. It is called constructor. Within this method or this constructor, it takes a self, which means the instance itself as an argument, and also take name and grade as additional two arguments. So when those arguments are passing to the constructor the class has two instance variables called name and grade, which are taking value from the argument respectively. So that's the way how the constructor is being invoked, and then how the two instance variables are assigned with values within the constructor body. Lastly, inside the constructor, it will update the class variable student count. Whenever a new instance is created, the student count will go up by 1, increases by 1. Basically, that's the block of the constructor. Then within the class, we also have two methods, additional two methods. The first method, called display count, as you can tell, is very simple. It just displays the counts of total student, which is a class variable. And there's another method called display student. And within this method or function, it will print out the name and grade of a specific student or specific instant of the student class. You'll notice that for both methods, they have self as arguments in the function's definition. The self again refer to a class instance. They exist in the definition of a function, but when you call the function, you do not need to pass self again. So the whole block from here to here are the definition of a class. Now, how we use the class that we just defined, here are the way how you use it. So first we create a first instance called stud1, and we are passing the name as Andy, a grade of 8. Again, we do not need to pass self because self just refers to the instant itself, right? It exists in the function definition, but when you call this function as a function caller, you do not need to pass self. You only need to pass Andy as the name and the grade of 8. Basically, this one will create an instance of student, and correspondingly, the constructor, the init method, will be invoked, and then all the instance variable like name and grade will be assigned properly according to the values you are passing. Then there's a second student we're creating here, and this student has the name of Brandon of grade 6. Now we're just create the first student and create the second student. We're going to call the display student function for the first student and then for the second student, and we'll display the counts for the first student and the second student. Basically, that's what the code does. This just gives you an example of what does a class of Python look like. Now we can go to the spider and run the code and see the behavior of the particular class and the usage and of this class instances. And here is the class. So the class, we may just focus on this portion first, right? This class continues. There's also the inheritance, right? Let's just focus on this much. If we click on here, we execute the code, right? First, let me clear the console. If we execute it, so this has everything. And but what's relevant for this portion is up here. So because we define two students, Andy, 8th grader, and Brandon, 6th grader. Then later when we display student, it is called, it will call this method display student with name, actually with name Andy and grade 8, and display student 2 with name Brandon and grade 6. Then we call the display counts. Again, display counts are showing the total counts of all students, all the instances, since we have two instances. So no matter you're calling for student 1 or calling for student 2, for both cases, you're getting 2 as the outcome because we only created 2 students instances. So that's what part of the code does. So now let's continue. We're going to the concept of inheritance. Since we already defined a class called a student, now we want to define a child class of high school student. Basically, this is the syntax. We're defining a new class called a high school student, and here is the base class, the parent class student that we already defined. Basically, every high school student is a student. So we want to have the basic attributes, the features of student, but maybe it's something different for high school students. So this is why we want to have an inheritance. We start with the base, then we borrow, carry on mostly from the base, but then we have some degree of change in the child class. That's the whole concept of inheritance. So again, we come into the init, the constructor of the high school student. And it has name, grade. Now we have something new called the GPA. So GPA is the last argument to the class. As we can see, the GPA is a default argument. That means this, if you do not pass a GPA, and the GPA will be 3.8. So this GPA is a new attribute, new data member, and new instant variable to the class. Because high school student now GPA counts, right? So we want to define a new attribute called the GPA. But the GPA again is a default argument. If you do not specify it, the 3.8 will be taken as a default. So then within the high school student constructor, it first just like invoke the base class, the parent class students constructor, passing the name and grade. Only thing special is you want to specify the instance variable of GPA based on the value you're passing. In case you do not passing, again, you're taking 3.8 as the default. So this makes the constructor of the high school student class. Then again, we have a new method called display GPA. Basically just prints the name and the GPA of a student, high school student. Finally, we have a method of display student. You will remember display student also exists in the parent class. But the behavior between the parent class and the child class slightly different. So in here, in the high school student class, we are printing the name, grade, as well as GPA. Again, in the base class, you do not have a GPA. You just print the name and grade for student, right? Printing GPA as part of the information of student is something unique to the high school student. Now here, we actually created two instances of the high school student. The first one was Steve as a name, 10 as a grade, and GPA 4.0. Then we call the display GPA function of the student 1. Then we create a second instance of the high school student. Now we have a name Alan, 10 grade, but we do not have a GPA, right? So what's going to happen? The GPA will be 3.8, right? Because it's default value for this argument. Then later we will call some functions associated with the second high school students. Eventually we'll also have printing in the end. Now let's go back to the code and see what we get from the code execution. Since we already executed this code, when we click on the button, the run button first time, and this block represents everything from line 29 in the code, right? So the first one is this code. We are creating a new high school instance. And then, so that's why, whenever this constructor is called, there's a one line just print out showing, hey, the child constructor block has been entered. Then we display the GPA of first student. Since we put the 4.0, so we'll display it, and this line, this actually function being invoked and showing the name is Steve, and the GPA is 4.0. So then we have a second student. We put Alan and grade 10. There's no GPA, but when we call the display GPA function, it will showing Alan with the GPA 3.8 because 3.8 is the default if the GPA argument is not being specified. Now we have display student information. So we want to basically, this one is only applied to the second student so far. So this block will be invoked, and it tells us actually, this line is being invoked. Yes, the second student is called Alan, grade 10, GPA 3.8. Basically, this is what for the second student look like. And finally, we want to count all students. Well, we're calling from the high school student instance 2, right? So we're counting, we're getting 2, getting 4. Why is that? Because early on we have 2 students from the base classes. We have another 2 students from the high school students, and such a student count is shared across all the instances. So we have 2 students plus 2 high school students. In total, we have 4 students. So this is an example of the class and objects. Finally, let's look at the modules. So module is a file, the Python file contains definitions of functions, classes, or variables. You group all the relevant stuff into one file. So important things is you put the relevant stuff together. So it will be easier to understand, you use what you have included in one module or one file. And one module may also have main method, make it runnable. So the idea again behind the module is reusability and easy to understand. So the module, the way you do it is you will have import. You import module 1, 2, 3, or as many as you want. You put a comma in between to separate. So to look at the module import, we're going to look at one example, the guest number indentation. The Python program we looked at last time, it imports random package, random module. And we're going to take a look at this particular Python code. So here's the Python code, okay? And here This remaining part, you're probably already familiar with it. We're not going to spend much time to talk about it. The only thing I want to let you know is the import random. So the random is a module we're invoking. It's part of the Python package. So if I hold the control key of the computer's keyboard and also put the cursor on the random and click it, actually with the spider's ID will opens up the random.py, the module, and you can examine the further details within this particular random.py module. And you can see within this module, it actually imports other modules. This is the whole concept of reusability. You want to build the new stuff on the basis of existing modules and some other people's work. And here within the random, there's also creation or definition of the random class. So yeah, this is a concept of module, and you import a module into your own program for your own usage and your extension of other people's work. So lastly, I want to show you something uh, not directly for your day-to-day programming or the usage of Python programming itself, but certain like thinking, certain principles behind the design of Python programming language. It's called the Zen of Python. So then itself is a concept from Buddhism. Zen emphasizes self-control, meditation, and searching for insights, deeper insights about life and the world. Obviously, getting a deep understanding or insights may take a very long time and require experiences. So basically, Python, the then of Python is a bunch of principles that influence the design of the Python programming language. So even for users, programmers of Python programming language, understanding these principles and practice on those principles are pretty good. Make your programs are more robust, um, more reliable. But not all the principles are that easy to get. Just like a Zen, it may takes a long time and takes a lot of practices and experiences even before you can make sense out of those principles. It's just like Zen. It takes time to digest and to internalize. Just bring this to your attention. Yeah, take a look. You may get more and more as time goes. And that's all for today's session, and it concludes our review of the Python programming language. Next time, we're going to jump into the machine learning